Hi guys, I'm not sure if I got cut off in the last video, but if I did, I was just showing that if we go back and plug in negative 13 to the equation, negative 13 minus 2 equals negative 15. Okay, so in this video, we're going to take it one step further. You could say we're going to go on X Games, bro. For those of you that are TikTok fans, we're going to now do multi-step equations. So to save some time, I have pre-written the equations down. So take a moment to copy down these three equations. If we have time in this video, as I'm doing it, I may do a fourth one, but go ahead, pause the video, copy down these three equations on a new sheet of paper. When you are done, go ahead and start back up the video. Okay, so we are going to go through and solve these equations. You will notice that it's not as simple as just using one inverse operation to figure out the value of our variable, okay? We are going to actually have to go through and use our three-step process, combining like terms, getting rid of the constant, and getting rid of the coefficients, okay? We're still going to use inverse operations to solve. Our goal is to get x by itself still. So if we look at the first one, and I apologize for the sun shadow that's coming through on my window, but my succulents are getting sun, which is nice. Okay, so we have 3x, or 3 times x, minus 18 equals 6. So first step, combine any like terms. I do not have any like terms that I need to combine. I have my coefficient, my variable, my constant, and my solution. Okay. The next step, according to our steps, is we want to get rid of the constant or get rid of the buddy. This is kind of like our x's friend, but not really our x's friend. It's considered our buddy. So we're going to use the inverse operation. This constant is being subtracted. So the inverse, or the opposite of subtracting, is adding. So we are going to add 18 to 6 in order to get rid of it. This is the addition property of equality. I'm just abbreviating it. Okay, addition property of equality. And so if we do this, our new equation is going to be 3x, and then minus 18 plus 18 kind of cancels out to 0. 3x equals 6 plus 18, which is 24. This is our new equation. Okay, so now we're going to look at our new equation and again determine what's the inverse operation we need in order to get x by itself. That's our ultimate goal. Well, we got rid of our constant and now we need to get rid of our coefficient, x's best friend. It's the harder thing to get rid of, so that's why we solve it second typically. So in order to get rid of the coefficient 3, this is 3 times x. So we're going to use the opposite of multiplication to solve. So we are going to divide 3 from both sides of the equation to get x by itself. And when we do this, we get 3 divided by 3 is just 1. 1 times x is x. 24 divided by 3 is 8. So x equals 8. And what we used here, we use the division property of equality. We use the division property of equality to solve. We use the inverse operation. Okay? So for problem 2, and again, to check our answer, we could go back and plug in 8 for x and solve, do 3 times 8 minus 18, and make sure that we get 6. For 2, you need to distribute, right? We don't know how we can get x by itself. So we're going to use the distributive property. We could divide by 4 from both sides. We could start off by doing that. But it's just going to be easier if we set up using the distributive property. So if I distribute, this is now going to be 4x minus 28 equals 7. 4x minus 28 equals 7. I distributed that 4 to x and to 7. So pause the video right now and see if you can solve this using inverse operations. Okay, so if you solve this, the first thing you need to do is get rid of 28. So we are going to add 28 to both sides because that is the opposite of subtraction. Our new equation is 4x equals 7 plus 28, which is 35. I'm going to rewrite it over here so I have some space. 4x equals 35. To get x by itself, I'm going to do the opposite of multiplication because 4x means multiplication. I'm going to divide by 4. So x is going to be equal to 35 over 4. We can leave it as an improper fraction. Okay, this video time is about to run out, so I will make one more video going over the last 2 examples.